Okay, in this presentation we are going to look at the negative binomial distribution. So we have a question here. A large lot of tires, like car tires, contains 5% defective. So 5% of the tires in this car tire collection are defective. So essentially what we want to do is select 4 tires. So 4 tires are to be chosen at random for a car. Okay, now potentially there are defective tires. So if we find a defective tire, we have to just pick out another one again. So this is the whole point of the question. Find the probability that you find 2 defective tires before you find 4 good ones. Okay. The second question is find the probability that you find at most 2 defective tires before you find 4 good ones. And then find the mean and variance of the number of defective tires you must find before finding 4 good ones. Okay. Now, this is just important here, actually reading the question. Find the probability that you find 2 defective tires, okay, before you find 4 good ones. So this asks us to count the number of failures before we have enough successes. Okay, that's important because there's 2 ways we look at. There's multiple ways we can look at the negative binomial distribution. So in the first instance, this is one approach, or one sort of setup for the binomial distribution, because there are multiple, where x is the number of failures given r successes. Okay, that's exactly what we want here. Perfect. Okay, the probability mass function is given as follows. We'll come back to that shortly. There's a binomial coefficient of k plus r minus 1. From that, choose r minus 1. 1 minus p to the power of k, and then p to the power of r. R is the number of successes. In this case, it's 4. K is the number of failures, which is what we're going to be asking in the question. And P is a probability of a success. Now, just to coincide with that, there are special expressions of the expected value that correspond to that probability mass function. Okay, so that's the mean and the variance there that would correspond to this probability mass function. So just be careful of that. Just don't get mixed up. That's sort of part of the hazard with these questions, actually, the negative binomial distribution. This is an alternative approach, okay, where x is the number of trials. That's not what we're asked, given our successes, okay. So that's probably we're probably going to use that in a different question here, okay. So this is a different formulation, and really this doesn't help us. This is the total number of trials, okay. How many times do we have to pick out how many tires do we have to pick out before we get 4 good tires? So same question, the same concept, but just a totally different way. You can go from one to the other, okay. But again, just for the sake of clarity, you find 2 defective tires. That's what we were asked for, so we're going to go with the first one. I think I made my point. By the way, that there would be different formulations of the negative binomial distribution, mean and variance there for that second formulation. Okay. Anyway, so part A, let x denote the number of defective tires you find before you find 4 good tires. All good so far. A large lot contains 5% defective, so the probability of a good tire is 0.95. The random variable x is distributed as a negative binomial random variable where r is equal to 4, okay, 4 good tires, and p is the probability of success, 0.95. Okay, just sort of state that in your question, just to sort of make it clear what you know what you're doing. Okay, yeah, actually, just a sort of remark, be very clear that you explain that. Now this is very important to actually describe what x is, particularly in the case of a negative binomial distribution, more so than Poisson and binomial, because there was less uncertainty about those. But when you go into other things like the geometric and the negative binomial, where you have to be very precise about what you're asking, you know, you have to sort of spell it out exactly. Okay, so that's an important thing to remember. Okay. So the probability mass function, the probability of x equal to x, capital X being the variable name and small x being some number, okay? That is the binomial coefficient of x plus 4 minus 1, which is x plus 3. So essentially, the binomial coefficient of x plus 3, choose x, okay? P is 0.95 and r is 4, so 0.95 to the power of 4. That is going to feature in all of our calculations for probability calculations going forward, and 0.05 to the power of x. Okay, so that is the probability mass function with the appropriate numbers there here. Okay, that one there. Okay, so what we do is let x equal to 2, probability of x equal to 2. 2 plus 3, x is and x is 2, so we end up with the binomial coefficient of 5, choose 2. From 5, choose 2, we should end up with 10. Okay, that's what's going on here. 10 there, so 10. 0.95 to the power of 4, that is 0.8145. And 0.5 squared, that is 1 minus p, otherwise known as q, to the power of x. 0.05 to the power of x is 0.05 squared. 0.0025. Multiply it all out, and we should get an answer close to 0.0204. So that is the probability that x is equal to 2. Now, the second question is, what is the probability that you find at most 2 tires before you find 4 good ones? Okay, well, essentially what we have to do here is just calculate the probability of x equal to 0, probability of x equal to 1, and the probability of x equal to 2, which actually we have already. So essentially what we have to do is just calculate the probability of x equal to 0. That's actually a very straightforward calculation. X equals 0, so 0 plus 3, choose 0. From 3, choose 0, that's just 1. And 0.05 to the power of 0, that's 1 as well. And this number we've used it previously, so that is 0.18145. Okay, that's the probability of x equal to 0. And now we have to do the same thing with the probability of x equal to 1. 1 plus 3 is 4, so the binomial coefficient of 4, choose 1, is 4. 0.95 to the power of 4 times 0.05, so that is 0.8145 times 0.05. Remember, we're going to use that number quite a lot, so we don't have to keep recalculating it. That should work out to be 0.1629. So when we add up the 3 numbers here together, we should end up with 0.9978. So 99%, almost 99.78%. Now, finally, the mean and the variance of the defective tires you must find before you find 4 good tires. Well, this is the expected value of x. Now, just remember, this is formulation of the expected value is particular to the formulation of the probability mass function. Okay, so r times q over p, which is essentially r times 1 minus p over p, and that is 4 times 0.05 divided by 0.95. That gives us 0.2105. Okay, so on average 1/5 of a defective tire, if you will. We can get a real number as an answer to an expected value, even if the probability distribution is discrete. Same again, the same calculation there. Same type of calculation. R times q divided by 1. R times q divided by p squared. R times 1 minus p divided by p squared. That is 0.4 times 0.05 divided by 0.95 squared, and that is 0.2216. Okay. So it's actually a very quick calculation. Once you have that, you just divide by 0.95 again. Alright, that's grand. That's the negative binomial distribution. We'll leave it there.